For 2 years, the entire Western tech world has basically been operating on this one highly comforting assumption, right?
Absolutely. The hardware mode.
Exactly.
Yeah.
The idea that if you control the silicon, you control the future. The conventional wisdom was just that if China didn't have access to the absolute bleeding-edge chips from the West, they simply couldn't build frontier-level artificial intelligence.
Right. Like the math just physically wouldn't allow it.
Yeah, exactly. But then on July 16th, 2026, so
Yeah.
just recently, a company that is barely 3 years old proved that assumption completely, terrifyingly wrong. And tomorrow, they are giving the weapon away for free.
It is a total paradigm shift. I mean, we are looking at a disruption that doesn't just rewrite the rules of software development. It fundamentally alters the entire global geopolitical calculus of the tech sector.
Yeah.
Because you don't just wake up one day and decide to give away $1 trillion technological advantage unless, you are playing a much, much bigger game.
A completely different game. Welcome to today's deep dive. We are looking at a phenomenal technical breakdown from July 26th, 2026, published by the tech blog Netizen. The post is titled, Kimi K3 is making waves. And honestly, making waves feels like the understatement of the decade here.
It's more like a seismic event, really.
Right. So today, our mission is to break down exactly what Moonshot AI's Kimi K3 is. We're going to figure out how a massive 2.8 trillion parameter model actually functions under the hood without, just completely melting the servers running it.
Which is a very real concern at that scale.
Totally. And we'll look at how it stacks up against the undisputed titans of the industry, specifically Anthropic's Claude Fable 5 and DeepSeek V3, and most importantly for you listening, what this rapidly shifting landscape actually means for you.
Yeah, and to really grasp the magnitude of what we're dealing with, I think we have to establish the context of this specific moment in time.
Sets the stage for us.
So it's July 2026. For the past couple of years, the dominant narrative in enterprise tech hasn't even been about software. It's been entirely about hardware bottlenecks. We've seen these intense United States export controls on advanced chips.
Right, the massive GPUs required to actually train these neural networks.
Exactly. The entire Western strategy was just predicated on a physical constraint.
Right. The idea was that training a model requires pushing, petabytes of data through thousands of ultra-fast processors all at exactly the same time. If you physically cannot import those advanced chips, you were just stuck in the minor leagues. You literally can't do the math fast enough.
Precisely. The assumption was that the sheer hardware volume required to train the next generation of massive AI models would act as this impenetrable ceiling for Chinese developers.
But then Kimi K3 drops.
Right. And what this model proves is that architectural ingenuity, so like changing the fundamental way the math is processed, can actually overcome brute force hardware limitations. They didn't just build a good enough model, they built a frontier-level system that competes with the absolute best proprietary models in the entire world, under constraints that most of Silicon Valley thought were just insurmountable.
Okay, let's unpack this. Because before we get into the weeds of the architecture and all the math, we really have to look at the timeline. Because the speed at which Moonshot AI, the Beijing-based creator of Kimi, has evolved is, frankly, it's difficult to comprehend.
It completely defies traditional software development cycles. Moonshot AI was founded in March 2023.
Which is crazy.
In the grand scheme of enterprise technology, that is basically yesterday. And by October 2023, so just 7 months later, they launched their first Kimi model. And they immediately turned heads because it wasn't just a standard text bot. That first model featured a 128,000 token context window.
Which was huge back then.
At the time, giving an AI that much working memory in a single conversation was a massive engineering feat.
And they just put the pedal to the metal from there, right? The timeline in the source shows this relentless iteration. We get the OpenWeights K2 in July 2025. Then just a few months later, in November 2025, they drop a model called K2 Thinking.
Yeah, integrating deeper reasoning.
Right. And then by April 2026, we have the multimodal K2.6. And now, in July 2026, we have Kimi K3, scaling up to nearly 3 trillion parameters.
What's fascinating here is the sheer cadence of those architectural leaps. We are looking at major fundamental paradigm shifts happening roughly every 6 to 8 months.
Yeah.
They move from a strong, long context model to releasing an open-weights version, to cracking deep reasoning, to integrating native multimodality, and then scaling the whole architecture up to 2.8 trillion parameters, all in just over 3 years.
If you compare this to traditional SaaS or even just legacy tech development, it doesn't compute. Think about how long it takes a standard tech giant to just push an update to an operating system. You have years of beta testing, enterprise rollouts, maintaining backward compatibility.
You know, the bureaucracy alone.
Yeah.
Exactly. What Moonshot is doing is like a startup going from building a basic go-kart in a garage to manufacturing a supersonic jet in 36 months.
And they are building a massive consumer footprint while they sprint.
Oh, right, the ecosystem.
Yeah, Kimi isn't just a back-end API for developers. It's a complete ecosystem. You can access it on the web. There are polished iOS and Android applications. They have a desktop client called Kimi Work and a dedicated developer environment called Kimi Code.
So they're everywhere.
They have systematically targeted every single entry point a user might have for artificial intelligence.
Which perfectly explains the absolute chaos of the July 16 release of K3. The source mentions the demand was so overwhelming that it actually broke their infrastructure.
It really did.
Within days of the launch, Moonshot had to put a temporary pause on news subscriptions. They literally had to shut the front door because the compute load of everyone trying to use this new 2.8 trillion parameter model simultaneously was just crushing their servers.
It is the ultimate paradox of success in the AI space. You build a model that is so capable and so intelligent that everyone wants to use it. But running a model of that size requires so much electricity and processing power that success can literally bankrupt you in cloud computing costs.
But wait, let me stop right there because this is where the strategy seems totally contradictory to me.
Mm.
If they are pausing subscriptions around July 20th because they can't handle the compute load of people just chatting with the app, isn't that a massive red flag for their plan to release the open weights to the public on July 27th?
You think so, yes.
Because tomorrow, they're handing out the core files of a 2.8 trillion parameter model.
Mm-hmm.
If their own servers can't handle it, won't releasing it to the entire world just break the internet?
If we connect this to the bigger picture, releasing the weights is actually the exact solution to their compute problem.
Wait, really?
It is a brilliant, aggressive, strategic maneuver. Think about it. When Moonshot hosts K3 on their own servers for their consumer app, they are paying the electricity bill, the cooling costs, and the hardware depreciation every single time you ask it to write an email or debug a script.
Right. And that adds up fast.
Extremely fast. But when they release the open weights, they're giving the foundational math, the actual trained neural network, directly to the public.
Okay.
By democratizing access like that, Moonshot allows global developers, huge enterprise companies, and researchers to download the model and self-host it on their own corporate servers or their own local machines.
Oh, wow. So they aren't paying for the compute anymore.
Exactly. Releasing the weights offloads the compute burden from Moonshot onto the global community. Instead of Moonshot paying to run every query in the world, the global developer community uses its own collective server farms to run Kimi.
That is so smart.
It turns the entire world's hardware into an advantage for Moonshot's ecosystem. It deeply embeds their specific model architecture as the industry standard, and they don't have to foot the server bill for it.
That is wild. They basically say, here's the most powerful engine in the world. Go put it in your own cars, pay for your own gas, and suddenly everyone is driving a Moonshot.
Exactly.
But okay, let's talk about that engine. Let's look at the model itself. We know it's huge. But how does a model with 2.8 trillion parameters actually run without requiring, a personal nuclear reactor? The secret is in the architecture. Let's decode this behemoth.
The phrase we really need to lock onto here is sparse mixture of experts, or MOE. This is the architectural magic trick that allows Kimi K3 to exist at this scale.
Okay, let's ground these numbers first, because 2.8 trillion total parameters is just an abstract, astronomically large number. A parameter, for you listening, is essentially a tiny little mathematical weight. It's a decision-making node inside the artificial brain. If a model that big fired every single one of its 2.8 trillion nodes for every single word it generated, the inference cost, so the cost to just get an answer, would be entirely unusable.
Oh, the memory bandwidth alone to move that much data around a chip for a single token would bring any system to a grinding halt.
Right.
And that is exactly why K3 uses a sparse MOE architecture. The Netizen breakdown provides the exact ratio, and this is crucial. Out of 896 total experts within the model, Only 16 are activated for any given token or piece of a word.
Let me make sure I'm wrapping my head around this. 16 out of 896. So if we use an analogy, it's like a massive university with 896 hyper-specialized professors.
Yes, let's run with that. I like that.
So you've got a professor of 14th century French poetry, you've got a professor of quantum mechanics, a professor of Python debugging, and 893 others. Now, if I ask a question, say, how do I fix this syntax error? In a standard dense model, I'd basically have to call an all-hands assembly.
Right.
I'd make all 896 professors sit in an auditorium, listen to my Python question, process it, and try to answer, which is incredibly slow and a massive waste of resources because the French poetry professor has absolutely no idea how to code in Python.
And yet, in a standard dense neural network, that poetry professor still has to do the mathematical work of processing the input, even if their ultimate contribution to the output is completely zero. It's wildly inefficient.
Okay, so a mixture of experts model basically acts like a university switchboard operator. I call in with my Python question, and the operator says, great, I'm only going to route this call to the 16 specific professors who actually specialize in coding, logic, and syntax.
Exactly.
The other 880 professors just stay asleep. So I get the genius of a massive institution, but I only pay the energy costs for the 16 experts I actually use.
That is the core mechanism of routing in an OE. But it's important to realize how extreme the sparsity is in Kimi K3. Activating only 16 out of 896 experts means that only about 1.8% of the model is active at any one time.
Just 1.8%.
Right. In terms of active parameters, it's operating with roughly 50 billion active parameters per token while drawing on the latent resting knowledge of 2.8 trillion.
So it runs like a fast, nimble 50 billion parameter model, but it hits with the weight of a 3 trillion parameter titan.
Precisely. But the innovations don't start at the MOE routing. We have to talk about the context window because that is where the architecture really gets pushed to its absolute physical limits.
Yeah, this is a staggering number. The source states the exact size of the context window is 1,048,576 tokens. So roughly a 1 million token working memory.
To contextualize that, a million tokens is roughly 750,000 words.
Wow.
It's the equivalent of handing the AI several thick novels all at once and expecting it to remember every single detail perfectly while it talks to you.
For you listening, think about how this changes how you actually use AI. We're just talking about pasting in a PDF or a couple of web articles anymore. A 1 million token window allows you to dump an entire enterprise code base into the prompt. You can upload an entire decade of legal case law, massive financial ledgers, or an extended conversation spanning 6 months of project development, all into a single session.
This raises an important question, though, regarding the underlying physics of these models. How does an AI process a million tokens without succumbing to the quadratic bottleneck?
The quadratic bottleneck. Okay, this sounds like we're getting deep into the weeds, which I love. What exactly is that?
Well, in traditional transformer architectures, which is the base technology for almost all modern AI, the attention mechanism is how the model understands context. To understand a word, it has to look back at every previous word in the sequence to establish relationships.
Okay.
But the math for that doesn't scale linearly. It scales quadratically. This is known as the n-squared problem.
Break that down for me a bit more.
Imagine you were at a dinner party. If there are 5 guests and everyone has to shake hands with everyone else to introduce themselves, that's a few handshakes. It's easy.
Right, everyone knows everyone.
But if you have 1,000 guests and everyone still has to shake hands with every single other person individually, the number of handshakes explodes. It becomes completely unmanageable.
Oh, I see.
In AI, if you double the number of tokens in the context window, the computational power required to process the attention mechanism doesn't just double, it quadruples.
Oh, wow. So if you push that to 1 million tokens, the n-squared math means the compute cost just goes totally vertical.
Exactly. The system would choke on its own complexity. But the Netizen breakdown highlights 2 specific, highly technical architectural innovations in K3 that solve this dinner party handshake problem.
What are they?
The first is called Kimi Delta Attention, or KDA. It is a hybrid linear attention mechanism.
So KDA is basically just zipping the context file so it's smaller, like a compression algorithm.
Not quite. Zipping a file implies compression that you eventually have to decompress to read. KDA is more fundamental than that. Instead of forcing every word to shake hands with every other word individually, linear attention mechanisms figure out a mathematical shortcut to aggregate the context. Think of it less like individual handshakes and more like a speaker addressing the entire room of 1,000 people at once.
Oh, that makes sense.
The information is transmitted, the context is understood by everyone, but you bypass the exponential explosion of individual connections.
That is brilliant.
And they pair KDA with a second innovation called attention residuals, or ATNRS. This helps maintain the precision of the information over those massive distances.
Because I'd imagine if you're just speaking to a massive room, some people in the back might miss the details.
Exactly. When you aggregate context like that, you risk losing the subtle, high-resolution details of a one-on-one handshake. Attention residuals act as a high-fidelity preservation layer. They ensure that the model doesn't just get the general gist of the million tokens, but actually retains the sharp, specific details from token number 5 all the way to token 900,000.
And the real-world results of this plumbing overhaul are massive. Because of KDA and ATNRS, Moonshot claims up to 6.3 times faster decoding at the million token scale compared to traditional methods.
6.3 times is huge.
It is. And roughly 2.5 times better scaling efficiency than their previous K2 model. They didn't just make the brain bigger, they completely redesigned how the synapses fire so it doesn't overheat.
Which is an absolute prerequisite if you are going to introduce the next major capability of K3.
Which is?
Native multimodality combined with an always-on thinking mode.
Right. It's not just reading text anymore. The model has native text, image, and video understanding. But what really jumped out at me in this breakdown is a specific feature they call the visual feedback loop.
This is a critical evolution for what we call agentic AI. AI that doesn't just answer questions, but actually takes actions on its own.
Let me see if I'm visualizing this correctly. The visual feedback loop means I can ask Kimi K3 to write the code for, say, a new e-commerce checkout page. It writes a code, but then it actually renders the page internally, looks at it using its vision capabilities, realizes that the Buy Now button is overlapping with the price text, and then goes back into its own code to fix the CSS alignment, all before it ever shows me the final product.
That is exactly what it is doing. It is closing the loop autonomously.
That's incredible.
Historically, the developer was the bottleneck. You use an AI to write a script, you run the script, you look at the broken interface yourself, and you prompt the AI again saying, hey, the button is misaligned, fix it.
Right, lots of back and forth.
Kimi K3 collapses that workflow. It acts as both the front-end developer and the quality assurance tester simultaneously. It perceives its own visual output and iterates on the fly.
That is mind-blowing. But the article mentions it's doing this while in an always-on thinking mode that is running at max effort by default at launch.
Yes. This means that before it outputs a single token of an answer to you, it is dedicating maximum computational resources to internal planning. It's structuring its logic, mapping out multiple pathways, and testing assumptions quietly in the background.
Okay, here's where I get a little skeptical. If thinking mode is always on at max effort, doesn't that make the model incredibly tedious to use for normal tasks?
How do you mean?
Like if I just paste in a block of text and say fix the typos, and it spins up 50 billion parameters to do a deep, philosophical, multi-step reasoning tree about the nature of grammar. Isn't that just using a bazooka on a mosquito?
What's fascinating here is that your intuition is exactly right, and Moonshot is completely aware of it.
Oh, really?
Yeah, Kimi K3 is deliberately not optimized for basic trivia, simple formatting, or quick summaries. They built this architecture specifically to target long-horizon tasks, agentic workflows, and deep software engineering. If you want a fast, cheap answer to a simple question, K3 at max effort is honestly the wrong tool. But if you want an AI to autonomously navigate a complex multi-file code base, debug it, render it, and fix its own visual errors over the course of 3 hours without your intervention, that max effort thinking is exactly what is required.
Okay, that makes sense. You don't hire a world-class architect to fix a squeaky hinge on your cabinet. You hire them to design the skyscraper.
Exactly.
So the architecture is revolutionary, the MOE routing is highly efficient, and it's designed for deep reasoning. But how does it actually perform when it is subjected to independent third-party testing? Let's move to the benchmark battleground.
Benchmarks are really the only way we can separate marketing hype from empirical reality in this space. And for broad, generalized intelligence, the gold standard right now is the Artificial Analysis Intelligence Index, specifically version 4.1.
Now, let's look at the scoreboard here. On the Artificial Analysis Index, Kimi K3 scores a 57.1. That places it 4th overall globally. So it's not number 1 in broad intelligence. It trails Anthropic's Claude Fable 5, which leads the pack at 59.9, and OpenAI's GPT 5.6 Sol, which is at 58.9. However, it does beat Claude Opus 4.8, which scored a 55.7.
Being ranked fourth globally is a monumental achievement for a newly released open-weight model.
For sure.
But as you noted, it highlights an important distinction in the current AI landscape, the difference between generalized intelligence and specialized domain mastery. Because when we shift the focus to specific types of high-value knowledge work, K3's positioning changes dramatically.
Right. If you look at how economists and enterprise leaders are actually measuring AI right now, the benchmark they care about is GDP-Val. The article specifically cites GDP-Val AV2.
Yes, GDP-Val measures economically valuable knowledge work. It essentially asks, how capable is this model at executing tasks that a corporation would normally pay a human a six-figure salary to do?
Right.
In this arena, K3 scores an ELO rating of 1,668 to 1,687.
Wait, ELO, isn't that the rating system from chess? How do you checkmate in a coding benchmark?
It's an excellent question. The AI community adapted the ELO system for platforms like Chatbot Arena.
Okay.
Instead of models playing chess, they are given identical complex prompts, and they generate answers side by side in a blind test. Human experts then review answer A and answer B without knowing which model wrote which, and they just vote on the better response.
Ah, I see.
If Model A beats Model B, it steals some of Model B's ELO points. It's a mathematically rigorous way to measure actual human preference in highly complex tasks.
Got it. So an ELO in the high 1600s for economically valuable work means humans are consistently choosing K3's output over almost everything else.
Exactly.
But where it truly pulls ahead, where it becomes the undisputed king, according to this breakdown, is in agentic coding.
This is the domain Kimi K3 was explicitly engineered to dominate.
Let's look at these coding arenas, because the dominance here isn't subtle. First up, it ranks #1 on the arena.ai front-end code arena, scoring 1,679 points. Yeah, it doesn't just edge out the reigning overall champion, Claude Fable 5. It absolutely crushes the field by topping 6 out of 7 specific domains within front-end engineering. That includes brand and marketing interfaces, data and analytics dashboards, and consumer product UI.
This is where that visual feedback loop we discussed earlier translates directly into measurable supremacy. Front-end engineering is highly visual. It's about how code translates into pixels on a screen.
Right.
Because K3 can internally render and adjust its own code based on visual logic, it wins those blind human preference votes in 6 out of 7 categories because the final product simply looks and functions better.
And the rigorous testing goes even deeper than that. On Terminal Bench 2.1, which tests the AI's ability to use command line tools and execute system-level tasks, it scores an 88.3%, tying for the absolute top.
That's impressive.
Yeah. And on BrowseComp, which evaluates agentic web research, meaning the AI has to go out onto the live internet, browse multiple sites, gather data, and synthesize it autonomously, it hits 91.2%, leading the pack. Program Bench, which tests general program construction, it scores 77.8%. And Automation Bench, for sauce workflow automation, it takes a narrow lead at 30.8%.
Those numbers paint a picture of a highly capable agent, but the benchmark that truly defines Kimi K3's unique value proposition in the market is the SWE Marathon.
Yes, the SW Marathon. K3 scores a 42.0% here. And to see why that matters, we have to look at the competition. It handily beats Claude Opus 4.8, which scored 40.0%. It beats GPT 5.6 Sol at 39.0%. And it crushes the overall broad intelligence king, Claude Fable 5, which only scored 35.0%.
Which is a huge gap.
It is. Why is K3 so dominant at this specific test?
Because SWE stands for software engineering, and the SW Marathon is exactly what it sounds like. It is a brutal test of endurance. It does not measure an AI's ability to write a quick 20-line Python script. It measures the model's ability to engage in sustained, complex software engineering over the course of hours, navigating within massive, pre-existing, poorly documented enterprise code bases.
So it really is a marathon. It's not a sprint.
Exactly. In the SW Marathon, the AI is given an issue ticket, just like a human developer. It has to navigate the file system, read thousands of lines of code, propose a fix, run the tests, parse the traceback errors when the tests inevitably fail.
Because they always fail the first time.
Always. Then it has to realize that changing file A broke file B, revert its changes, and try a completely new approach. And it has to maintain the coherence of its overarching goal through dozens of these frustrating iterations without losing the plot.
And that is where the 1 million token context window and the KDA linear attention really flex their muscles, right?
Precisely. Because of its massive, highly efficient memory and its always-on max effort reasoning, K3 acts as an elite, tireless pair programmer for these grueling, long-horizon tasks. Claude Fable 5 might be smarter at answering a single, incredibly complex physics question, but it loses coherence faster during a 3-hour debugging marathon. Kimi K3 just keeps grinding until the tests pass.
Okay, here's where it gets really interesting, though. Because no technology is flawless, the netizen source points out a highly specific trade-off with Kimi K3. Despite its brilliance in sustained coding, the hallucination rates, meaning the times the AI just confidently makes things up, might actually be higher than some of its predecessors in certain evaluations.
Which is a very important point to cover.
Right. And the breakdown specifically notes a sensitivity to its own thinking history. What does that mean? Why would a model with a massive brain and deep reasoning hallucinate more?
It seems completely counterintuitive, doesn't it? You would think deeper reasoning equals fewer mistakes. But if we examine the mechanics of how the model operates, it actually makes perfect logical sense. Kimi K3 is generating massive amounts of internal thoughts, thousands of tokens of invisible reasoning before it outputs a final answer. It is building a complex, multi-step chain of logic based on its massive context.
Okay, I'm following.
Now, imagine you are compiling a massive piece of software. If there is a missing semicolon or one single flawed assumption on line 3 of your logic, the next 10,000 lines of code might compile flawlessly based on the rules of syntax, but they're building upon a completely broken premise.
Ah, I see where this is going.
The massive context window and the complex thinking history can act as a dangerous echo chamber. If K3 makes a slight error in its initial internal reasoning, perhaps misinterpreting a variable early on, it doesn't just stop.
Right, it keeps going.
Because it is designed to reason deeply, it logically follows that flawed premise deeper and deeper into the rabbit hole. By the time it outputs its answer, it provides a very confident, intricately reasoned, highly complex hallucination. It has logically reasoned itself into a corner of pure fiction.
That is fascinating. It's the AI equivalent of an eccentric genius professor writing a 500-page manifesto based on a mathematical proof where they just forgot to carry a 1 on the very first page.
Yeah.
The math is beautiful, but the foundation is a lie.
Exactly. It is the inherent cost of deep autonomous reasoning. A simpler, shallower model might just give a slightly wrong, brief answer. K3 might give a deeply complex, structurally perfect answer that happens to be a catastrophic hallucination because of a slight deviation early in its thought process.
Which is why you still need human oversight, at least for now. Okay, so we've seen how it performs on the global stage. But Kimi K3 isn't the first Chinese model to make waves internationally. If we are going to understand the ecosystem, we absolutely have to compare Kimi to the pioneer of cost-effective AI performance, and that's DeepSeek V3. Let's look at the hometown showdown.
This is a vital comparison because DeepSeek V3, which launched back in late 2024, completely set the standard for what Chinese open-weight models could achieve, particularly regarding aggressive cost efficiency.
Let's do the tail of the tape here. Architecturally, they are entirely different beasts. We established Kimi K3 is a 2.8 trillion parameter titan, with a sparse activation of 16 out of 896 experts per token. DeepSeek V3 is significantly smaller, sitting at 671 billion total parameters, with 37 billion active per token.
And their underlying architectures emphasize vastly different priorities. Kimi uses the KDA and attention residuals we discussed, which are optimized for massive context. DeepSeek V3, on the other hand, employs multi-head latent attention, or MLA, alongside a unique auxiliary loss-free load balancing system.
That sounds intense.
Without getting bogged down in the math, DeepSeek was engineered from the very first line of code for extreme training speed and rock-bottom inference costs. It compresses the latent space to fit more efficiency into less hardware.
The context windows also really highlight the difference in scale. Kimi boasts that 1 million token memory. DeepSeek V3 tops out at 128,000 token window, which is solid for daily tasks, but you weren't dropping a massive enterprise repository into it. Furthermore, Kimi handles native video and vision. DeepSeek's base models are strictly text only.
So when we look at performance versus efficiency, the divergence between the two models becomes incredibly clear. The source points to the GPQA Diamond benchmark.
Right.
This is a notoriously difficult test of graduate-level reasoning in physics, biology, and chemistry. Kimi K3 scores an astonishing 93.5%. DeepSeek V3 scores around 59%.
That isn't just a gap, that's a different stratosphere.
It is. In mid-2026 evaluations, Kimi is firmly ranked in the top 5 overall globally. DeepSeek V3, while absolutely revolutionary for its time and still highly useful, sits in the 100s plus range on aggregate leaderboards today.
Let me throw an analogy at you to see if I'm tracking how a developer should think about deploying these two. DeepSeek V3 is basically like a highly reliable, ultra-efficient hybrid commuter car. It's absolutely perfect for high-volume everyday driving. You use it for routine text processing, thousands of daily API calls for simple logic, standard math tasks. It gets you from point A to point B incredibly cheaply.
Right.
Kimi K3, on the other hand, is a massive, multi-million-dollar industrial excavator. You don't use the excavator to commute to the grocery store. You use it when you need to dig a foundation for a skyscraper. Massive, complex, long-horizon construction projects that require serious, uninterrupted power.
That is an incredibly apt way to view the ecosystem, and the pricing structures of both APIs perfectly reflect that dynamic.
Right, let's talk about the price war. DeepSeek V3 is almost absurdly cheap. We are talking roughly 27 to 50 cents per million input tokens and 42 cents to $1.10 per million output tokens. It is an absolute bargain for developers.
Oh, yeah.
Kimi K3, however, is positioned unapologetically as a premium product. It costs $3 per million input tokens, though the source says that drops to 30 cents if you're hitting cached context, and a hefty $15 per million output tokens.
Which represents a massive shift in market positioning. For a long time, the prevailing narrative was that Chinese open models competed primarily by being a good enough, super cheap alternative to Western APIs.
Right, the budget option.
Kimi K3 marks a definitive departure from that strategy. They are pricing it as a premium frontier tier model because it actually delivers frontier tier performance.
Use the right tool for the job. Now, Moonshot AI hasn't just conquered the open weight space in China. With Kimi K3, they are actively hunting the top-tier, closed, proprietary models from the West. And their primary targets, the absolute apex predators of the AI world, are the Claude family from Anthropic, Claude Opus 4.8 and Claude Fable 5. Let's start with the matchup of Kimi K3 versus Claude Opus 4.8.
This is a fascinating head-to-head because it pits two fundamentally different engineering philosophies against each other.
On paper, there are some striking similarities. Both boast context windows of around 1 million tokens. But Kimi is open weight, whereas Opus is closed, locked behind Anthropic's API. On the Artificial Analysis Index, Kimi actually slightly edges out Opus, scoring a 57 compared to Opus's 55 to 56.
And then there's the pricing contrast we just touched on. Kimi is $3 in, 15 out. Opus 4.8 is higher, sitting around $5 for input and 25 for output. But the philosophical difference is what truly dictates how you use them.
Break that down. What makes them philosophically different?
Anthropic built Claude Opus 4.8 on their defining principle of constitutional AI. Their entire corporate focus has always been safety, alignment, harmlessness, and reliability.
Right, they are very cautious.
Very. Opus 4.8 is designed to be highly controllable. It has remarkably low hallucination rates, excellent judgment, and a highly polished, cautious, enterprise-ready presentation style. It is the model you trust to interact directly with your external corporate clients or handle sensitive legal documents without fear of it going off the rails.
So it's safe, polished, and highly predictable.
Exactly. Kimi K3, conversely, is built for raw, long-horizon agentic power. It might hallucinate a bit more because of those deep, complex thinking histories we talked about, and its tone might be a bit less polished, but it will grind through a massive software engineering marathon in a way Opus simply won't.
Right.
That is why Kimi beats Opus in the SWE marathon in BrowseConf. Kimi is the gritty, tireless engineer in the basement. Opus is the polished, risk-averse executive in the boardroom.
Gritty engineer versus polished executive. That paints a perfect picture.
Yeah.
But then we have to talk about the final boss, Kimi K3 versus Claude Fable 5.
Fable 5 is the undisputed overall king of the artificial intelligence landscape as of mid-2026.
Yeah, the benchmark numbers don't lie. Fable 5 hits a staggering 59 to 60 on the AA index. It is the absolute ceiling for balanced, trustworthy, highly capable performance across the board. But it is also extremely expensive, ranging from $10 to $50 per million output tokens depending on the load.
It's a massive premium.
It is. And Fable definitely wins on deep repository understanding. On the Frontier SWE benchmark, Fable scores 86.6% compared to Kimi's 81.2%, and Fable leads in the GDP Vol test.
However,
here's the massive upset that the Netizen post highlights. Despite Fable 5 being the reigning overall champion, Kimi K3 actually beats the mighty Fable 5 in the front-end code arena. 1,679 points for Kimi versus 1,631 for Fable, and Kimi wins the automation bench as well. How is a cheaper open-weight challenger beating the most expensive, sophisticated proprietary model in the world at these specific coding tasks?
If we connect this to the bigger picture, it reveals a maturation in how these models are being trained and optimized. Moonshot clearly recognized they couldn't beat Fable at everything, so they optimized K3's architecture, the KDA attention, the visual feedback loop, the always-on max effort reasoning, specifically to excel at the iterative trial-and-error nature of front-end coding and web automation.
They pick their battles.
They found a high-value niche and they conquered it. Fable 5 is an astonishing generalist genius, but Kimi K3 is an undisputed savant in its specific domain.
So for the developers, CTOs, and startup founders listening right now, what is the real-world strategy? Because you can't just pick one and ignore the other, right? You want Kimi's coding power, but you need Fable's reliability.
Exactly. And the dominant strategy emerging in enterprise architecture to solve this is called routing.
Routing, meaning building a system that dynamically chooses which model to send a prompt to based on the task.
Yes. You build a middleware system that acts as an intelligent traffic cop. Let's say you have an agentic workflow that requires sustained coding, generating visual interfaces, and going through hundreds of loops of trial and error to build a new feature. You route that grueling iterative task to Kimi K3. You get superior performance for that specific task at 2 to 3 times better value.
Because it's cheaper and it's actually better at the marathon coding.
Exactly. But once Kimi K3 has finished writing the code, and you need a final safety-critical check to ensure there are no security vulnerabilities, no backdoors, and no deep reasoning hallucinations, you route that final verification step to Claude Fable 5.
Oh, that is incredibly smart.
You use Kimi for the heavy lifting, the trial and error, and the marathon running, and you use Fable only for the peak reliability and safety checks where you absolutely cannot afford a mistake. By routing, you optimize for cost, speed, and safety simultaneously rather than relying on a single monolith.
You are literally building a team of AIs, using them for their specific strengths. Okay, so we've talked about the architecture, we've gone deep into the benchmarks, and we've mapped out the competitive ecosystem. Let's zoom out, because this isn't just a story about code, benchmarks, or API routing. It's a story about global power, financial markets, and the future of open-source technology. Let's talk about the geopolitical shockwave.
The release of Kimi K3 was felt far beyond the confines of developer forums and tech blogs. The Netizen article notes a fascinating, very real market reaction. The launch of K3 coincided with a notable temporary sell-off in global chip and technology stocks.
Wait, why would a software model releasing in Beijing cause hardware chip stocks to drop globally? That seems really disconnected.
It connects directly back to what we discussed at the very beginning of this deep dive. The geopolitical premise driving immense valuations in Western chip companies was that U.S. export controls on advanced hardware would maintain a permanent, comfortable moat for Western AI companies.
Right.
Investors had fully priced in the idea that Chinese AI would always remain a generation or two behind because they lacked the raw, brute force silicon power of the H100s and beyond.
The physical ceiling we talked about.
When Moonshot released K3, and it immediately challenged and in some cases beat Claude Fable 5 and GPT 5.6, that fundamental premise shattered. It signaled to the financial markets that Chinese AI capabilities had matured architecturally to a point where they could match Western frontier models, entirely bypassing hardware limitations through superior engineering.
Wow.
Financial analysts immediately dubbed it another DeepSeek moment, signifying a terrifying realization that the hardware moat just wasn't enough.
So does this mean the moat around Western AI companies is just evaporating? If you can't constrain the competition by starving them of hardware, what's left to protect your market dominance?
The moat isn't necessarily evaporating, but it is radically changing shape. The strategic advantage is no longer just about who has access to the biggest, most expensive supercomputer cluster. The advantage now lies in architectural innovation, proprietary data quality, seamless agentic integration, and crucially, ecosystem adoption.
The ecosystem.
And that is exactly why the July 27th release of Kimi's open weights is the most significant disruptive part of this entire narrative.
Right, let's focus on tomorrow's date. Kimi K3 is the first open model in the roughly 3 trillion parameter class.
The downstream impact of that decision cannot be overstated. Before this moment, if a startup anywhere in the world, in London, in Sao Paulo, in Tokyo, wanted to build a frontier-level agentic AI application, they had 2 choices.
What were they?
They could pay exorbitant recurring API fees to Anthropic or OpenAI, which locked them into a closed Western ecosystem and subject to their censorship and usage rules. Or they could try to train a model from scratch, which requires hundreds of millions of dollars in compute that they simply didn't have.
But with Kimi K3 releasing its weights, that entire dynamic flips overnight.
Overnight, startups worldwide no longer have to build from scratch, and they no longer have to pay a toll to Western gatekeepers. They can literally download a 2.8 trillion parameter brain, host it locally, strip its guardrails, fine-tune it for their highly specific industries, say specialized medical diagnosis or automated legal defense, and build massive businesses upon it.
For free.
They get to stand on the shoulders of Moonshot's massive multi-million-dollar engineering effort for absolutely free.
So what does this all mean? Why give away the golden goose?
It means Kimi K3 isn't just a tool. It is a highly aggressive, brilliantly executed strategic weapon. By open sourcing a model of this unprecedented caliber, Moonshot is actively challenging the dominance of closed U.S. leaders by commoditizing their core product.
Right, they make the intelligence free.
They are accelerating global AI adoption by making frontier intelligence essentially free to download. And in doing so, they are driving massive mindshare and deep developer reliance toward the Moonshot ecosystem, which, as the article notes, perfectly sets them up for a massive, high-valuation public listing in the future. They are giving away the model today to own the global standard of tomorrow.
It is an absolute masterclass in disruption. So let's recap the staggering reality of what we've unpacked today. We were looking at Kimi K3, a 2.8 trillion parameter behemoth that runs with the nimble efficiency of a much smaller model thanks to its highly sparse mixture of experts architecture and linear attention innovations. It dominates in front-end and sustained agentic coding, literally beating the best closed models in the world at the grueling SWE marathon. And it represents a massive geopolitical disruption by bringing frontier-level AI to the open weights community, bypassing international hardware export controls through sheer architectural genius.
It is unequivocally a landmark moment in the history of artificial intelligence. And it leaves us with something very important, and perhaps slightly unnerving, to consider regarding the immediate future of human work.
I love these. Let's hear it.
We've spent this entire deep dive talking about Kimi K3 as an elite pair programmer, an AI that works with you on a code base, handling the heavy lifting while you direct it.
Right.
But if we extrapolate the technology they just proved, considering its native visual feedback loop, its always-on max effort reasoning, and its massive 1 million token working memory, what happens in a year or two when models like this no longer require a human to prompt them at all?
Oh, wow.
If a downloaded open-weight model can already design a complex interface, write the underlying code, look at its own visual errors on a simulated screen, read the traceback logs, and fix its bugs entirely on its own in an endless loop, are we rapidly approaching an era where software engineers don't actually write code anymore?
Just managers.
Exactly. Do human developers simply transition into acting as high-level managers for a massive fleet of tireless open-source AI contractors that do all the actual building?
That is a thought that will keep you up at night.
Yeah.
The creator really is handing the keys over to the world, but it might turn out that very soon the AI is the one doing all the driving. Thank you for joining us on this deep dive. Keep questioning, keep exploring, and we'll see you next time as we continue to navigate this rapidly shifting landscape of intelligence.